Our next talk is by Kirils and Janis, and it's called A Deeper Journey into MikroTik Routers. Enjoy.
Thank you. Right, so those of you who've been following our research for this year already know that these routers can play music, so we're not going to touch that anymore today. You just had an opportunity to listen to a very nice song by that famous artist. Who the hell is he? Well, anyway. So today we're going to talk about MikroTik again, and we're going to discuss in a bit more depth what have we done for the past half a year and what are the new features that we discovered and what can we offer to you as a security and as a hacker community to work with and to maybe dig deeper and realize your own projects. And for those of you who've seen our presentation from a month ago, we actually have 53% new content. That's true. I counted just before the presentation. But we did attend a previous conference, and since then we've been busy hacking and working on new tricks to show you. And apparently the word got out that we're doing that. This is a message that I got from another speaker here at BalCCon, Tanoi, who's actually going to have a talk here in this room tomorrow about lateral movement in enterprise networks. So I'm actually a bit sad that I'm not in the same hotel as him, because then I could play around with that device there. And I would also like actually to extend thanks to Silvan. It is because of him. I met him first in BalCCon last year, and it's because of him that we actually got the idea to dig deeper into MikroTik, because we did some research before 2-3 years earlier, but we didn't find it really interesting. But actually, if we dig deep enough, it's quite interesting. So today I'm here with my colleague Janis. I'm a hacker. He's a hacker. So we hack stuff and things and break those things. Legal disclaimer, similar to the previous talk. So goal of this research is to achieve interoperability of computer programs, that is software running on MikroTik routers with other computer programs. Well, one example of that will be if you want to move your configuration, or if you want to move your certificates, which is even harder, to a different router, a MikroTik router, or maybe an entirely different router. There's really no tool to export the certificates to a different router. And you're not supposed to use the backup and restore functionality for that. So that's a no-no. Well, with jailbreaking, of course, everything's possible. We would also like to acknowledge some of the prior research that's been done in this field previously. Anthony++ from awmn.net forums on the initial NPK analysis, Drubica on NPK file unpacking, Paul McCall on sub-out riff analysis, and OpenVRT team on kernel config files. Because, of course, without them it would be impossible for us to do some of the things we do. But we are looking at some different methods to achieve the same and even better results. This slide here is for you. So in case some of you, and I know some of you here are passionate about MikroTik software and our hardware, you're welcome to join our team. And if you have the right qualities, right? If you have one or the other, right? Either you know Linux deep enough or you do reverse engineering deep enough, because we are still planning to work on that at least until the end of the year. Well, let's have fun. Just get in touch with us. So today we're going to talk about intro, just a small intro. We're going to talk about boot process and binaries, custom binaries provided by MikroTik on RouterOS. We'll take a look at package format just briefly. Probably a larger description of package format is going to happen in Hacktivity. That's a conference in Budapest in a month. We're going to take a look at config file format. That's new. We haven't seen it anywhere online. So we actually decrypted, well, not the right word, sorry. We actually decoded how the config files are stored on MikroTik. Those were XML 15 years ago. Now it's some binary stuff. And we're going to have lots of demos. So I know that here in Serbia it is hard to get by one of those devices, but they are quite used around the world. Brazil takes the top place, followed by Indonesia, and then Russia. And the big question, of course, with all hardware and IoT devices and also software online is, do you update your software? Well, this data was taken, was acquired approximately 3 weeks ago. At that time, the latest version was 6.40.1, which is the second data set here from the right. So that's your answer to the question, do MikroTik owners update their routers? Unfortunately, not so much. Okay, so let's start by looking at externals for RouterOS. And my colleague Janis would like to say a few words on what RouterOS actually is.
All right, so can you hear me? So RouterOS basically is a Linux kernel, and on top there are a lot of proprietary MikroTik software. Go forward. The thing is that MikroTik uses very old kernel. This one, 3.3.5, is used in the latest version. So all of them run on this one. And 3.3.5 was released in May 2012. So you can imagine that there are probably some problems there. Of course, MikroTik might patch those problems. Next slide, please. And since Linux kernel is GPL licensed, MikroTik is obliged to release those patches they use. And if you want, you can try to get it from them. Or if you don't want to contact them and ask them, you can just go to GitHub, because someone else has already put it there. I think we asked for a more recent version, right? And this is still the thing they gave us, was it?
Yeah, we got actually not that recent version at all.
Okay.
But to be fair, we were asking about a different version. We are, as you can see in the slides further on, we have actually updated our perception of the MikroTik ecosystem, and we are looking at some other vectors to access that. So we were looking at net install, and we asked the kernel for that, which actually matched.
Oh yeah, might be. So in any case, they provide the kernel patches and the configurations for all the architectures that you can build for. And if you go through all the patches, it doesn't seem like they have fixes for some of the vulnerabilities, but it might be that those vulnerabilities aren't really exploitable in their systems.
So if you have time, that's where you look at, right? You look at the patches and go through CVEs for the kernel, and maybe you find something cool.
Yeah, the patch file is something like 10 megabytes, so it's probably easy to go through it.
Yeah, that's why we haven't done that yet. Okay, so a brief history. This is a much shorter history than we presented a month ago. Just some important milestones. So MikroTik router software version 2 is actually 18 years old. MikroTik itself is 19 years old. And in 2001, they already had the package files mentioned in documentation as a method for extending functionality. Originally, they were used for updating, but they also managed to use them to extend functionality, which is what any good hacker would be looking at, right? Extending functionality of a router. They moved away, well, not away from x86, but they created some additional support for additional architectures. So MIPSEL, which is little endian MIPS, on the router board 500 in 2005. And they created I didn't really know how to call it. That's why I put backdoor in quotes here. It's not really a backdoor, since you can't really get in without knowing the admin password. But you get your root shell access, so that's not really supposed to happen. Anyway, they use it for development, as evidenced by the name devel-login. In November 2005, this string appeared in Nova bin login for version 2.98. And what it does basically is it checks if file on the router exists. Nova, etc, devel login. And if you log in with the username of devel and your password matches the password of the admin, then Ash the shell gets spawned for you. This is nothing new. This was actually discovered by, I think, separately. I do believe, honestly, that this has been separately discovered by the Chinese, by the Russians, and people in Europe. So it's nothing new. The question is, how do you make the file, right? If you have a hard drive that you can pull out of the system, like back then, it's easy. If you don't, well, it depends on your options, right? Fun fact that we added from the previous presentation, we dug a bit into the history, and actually, even before November 2005, there was a backdoor, and the username was previously bash, not devil, for that. And you could get the bash to spawn. The question is again, how do you change your shell setting for your user? And I think there's always going to be some possibilities to access MikroTik devices via shell, because they need to develop them somehow, and they're too lazy to do it otherwise. 3.21, we are still looking for this version of RouterOS. If anyone has it, please send it to us. We can't find it anywhere. We looked all over the internet, different languages, including some hieroglyphic sites written in hieroglyphs, and we couldn't find it anywhere. So we really want to take a look what the hell was wrong with that version that it's not available anywhere. In 2009, they created checksumming for these additional packages, right? NPKs for extended functionality. 2009, checksumming appears, meaning that we can't just create random extended functionality NPKs and upload them to our router anymore. So this is 8 years ago. And final history slide. For those of you who want to look into NPKs and reversing them, know that there's SquashFS employed since 6.0. And since November 2015, packages now include distribution channels. Now, distribution channels as versioning channels, right? Do you want to do development quality software? Do you want to work with release candidates, current, or bug fix if you want to stay behind stuff, right? That's nothing new, but it appeared in the packages. But we did look into actually trying to set the update branch on a live router. And you can do it like this. You can go to system package update, and you can do set channel equals development. And right now, the development channel is for 7.0, which is a large hype in the MikroTik community. They've been promising 7.0 to come out for 3, 4, 5, I don't know, some years. Some years, yes.
What kernel does 7 use?
We don't know, we haven't seen it. Because they've been promising it's going to come out, so we don't know what kernel 7 uses.
Not sure if it even is being worked on.
Well, I mean, if you set it to development, it gets file not found. And if you look at Wireshark, this is what happens in background. So it requests URL upgrade.mikrotik.com/routerOS/latest.7, which is not there or not available anyhow. So it is trying to request version 7 actually from the server, which is going to wait for that mistake when they mess up the permissions on that file, and then we're going to see what's happening there. But it hasn't happened yet. Right, so that's one fun thing that you can do. We also revisited the ecosystem, and we looked at it a bit more thoroughly. We still feel like we don't have everything in here. So we have access vectors in red. We have access targets, the ones that we want to access in blue. And there are mandatory components and optional components. Those are both, well, those are physical components of the device. And basically what we need to do if we want to go through it thoroughly, we need to look at every one of those orange boxes and see if it has any problems. We haven't done that yet. Notably, from the last version, we have added KVM here, which is a virtual machine actually provided by MikroTik to run different other Linux operating systems for routers, like OpenVRT inside MikroTik. Well, we are hoping to look to find some possibility to exit the virtual machine and get access to the host. Haven't worked on that yet. And we also, of course, looked at netboot and setup. And we also added backup files as a possible access target of interest. Right, let's look at a demo for RouterOS console. So while Janis gets that set up, some of you, probably many of you are using RouterOS, but as I learned last month, not many people use the console, actually. Many people use the web interface. So in order to understand the interesting part of the next couple of slides, it would be great if you understood how the console works.
Yeah, so they have this kind of cool idea in their telnet login, is that everything is structured under the major sections. So basically, if you add slash, then you have the big sections like system, user, IP, etc. So for example, if you go to log, and then either you go in there, like in a folder, it stays there, and now all the commands you do work in the log section. So that's functionality I haven't seen anywhere else. And it's pretty cool. So you can do all kinds of stuff. If you go to IP, address, and then let's say print, you can do all kinds of things from the console, but at the same time you're limited. You cannot do fancy things like you could do in Bash. If you know any other place, any similar other product like that, let me know.
About trying to access Bash through here, there actually was a vulnerability. We weren't able to locate specific version for RouterOS where this vulnerability manifested itself, but you could actually add a parameter to one of the commands. Command was supposed to write something to a file, but there's like this jail for those files, and you could try to escape the jail by specifying file name is slashes, and it actually worked. As well, Janis say it worked. We haven't managed to catch that live. Right, but the fun part here, important part here is that commands are hierarchical for MikroTik, and there's a lot to learn actually. Can we get the slides, please? So this is a command tree, I believe, for 6.40. Every dot on the screen, the resolution isn't high enough. We asked for 4K, but we couldn't get it. Every dot on the screen is a command or a parameter. On GitHub, link is going to be in the last slide. We actually created separate pictures for every top root command, like /IP, /interface, and so on. If I open them on my laptop with Xviewer, then opening PNG file for /IP takes up 4 GB of my RAM. So beware. Anyway, just to show you an example, we're going to take a look at this sector of the picture. At the log command example, this is how those look. Again, for those of you who work with the console and need a cheat sheet, or who want to learn the console, this might be good. You could use it to learn, right? You saw Janis demonstrating how console works. Here we see, and we use the same colors as in there, right? And the bold border there means that parameter requires a value. You can't just use it without a value. Okay, now, but those are externals, right? Anyone without having root access to a device can do that, so it's not that interesting. Let's take a look at internals now. We will go back again to Janis now for the boot process.
All right, now we actually need the slides. Yeah. So MikroTik made it quite simple because it has to run on all kinds of tiny devices. Obviously, no systemd there, thankfully.
Oh yeah, we should move to MikroTik as our desktop. No systemd.
Yeah.
Yay.
So basically, their kernel runs the init, and the init runs the main RC start script, which then in turn goes through all the RCD start scripts. And from there on, the main services, daemons are running that do all the functionality that MikroTik does. So this is how the RC start looks. And as you can see, there's something interesting. Yep. They use this path command binary that basically finds all the suffix paths in the prefix paths. So basically, could we get next slide? So if we look for path for etc RCD, it will look for that path in all kinds of different directories. And if you're jailbreaking MikroTik, and afterwards there are obviously file systems that are not writable, and then there are those that are writable. And since path includes also the writable paths, you can easily add your own startup scripts. You can add your binaries, and you don't have to worry about anything. Right? So RCD goes through runD, and it runs the S10 Nova script, which launches MikroTik's loader. And MikroTik's loader afterwards looks for their custom config files in X3 format. It's the binary. Are we going to talk about it later on?
Well, we don't have it separately, yeah.
Yeah.
We actually would like someone to help us with that. Not because we can't, but because we have more interesting stuff to do.
Yeah. So in their X3 files, they define like what processes should be run and managed by the loader. And the interesting thing is that all of the communication that happens between the processes goes through the loader using Unix sockets. So basically something basic. Next slide, please.
Right. And as MikroTiks are usually devices that are limited to memory, loader also starts them dynamically, right?
Yeah. Since not everything is needed during right after the boot, only when you run something, it's going to start it afterwards. And so there are some binaries, like loader that does the spawning. Then there's the watchdog that will watch if something fails, and if something fails, it will just reboot the router. Like if you used, I don't know, Linksys routers, if something fails, it will just keep going, and it's never going to come up. So MikroTik
is going to keep rebooting.
Yeah, it's going to keep rebooting. And sometimes it helps.
No, but there's actually a delay, like 1 minute or 3 minutes, so you can actually do stuff before it reboots.
There's a timeout of something, yeah. And then I have the master sys2 binary that manages all kinds of system settings, and it parses the received commands from the terminal. Next,
we have a theory. We believe that 2 in sys2 actually stands for RouterOS version 2. And maybe the binaries which are not in the Nova folder are there from version 1, but that's just a theory.
Yeah. And then they have the service manager, which is like, we're going to touch it later on, right? Yeah.
Right.
So the service manager, it's like in a daemon on Linux. It listens on all the important ports, and when necessary, it's going to launch a separate process, like SSH or, yeah. So here you can see process tree, where SSH appears only after user logs in using SSH. So it's handled by their service manager. Okay, let's keep going. Then there are some processes, daemons like that handle with network configuration, tunnels, and also AT commands if you use AT modems. Separate processes for managing firmware loading and kernel loading. Separate service for user and group management. Of course, log daemon, Winbox daemon. This is interesting, quickset. If you have used MikroTik web interface, there's this new thing called quickset, and quickset is separated from the rest of the web process. And well, we have a theory that it's probably because they might want to release maybe some very, very tiny and cheap machines that are not going to be able to run everything. So they might be like end-user oriented to run just the quickset. And quickset is being improved all the time. So separate service for safe mode support. In MikroTik, if you know, they have this cool feature, safe mode, that you can turn on. And if you, after it's being turned on, if you mess up configuration, and you cannot access the router, after like 15 minutes or so, it will reset back to the previous point before you started the safe mode. And of course, the web interface daemon.
Yeah, we are really looking forward to take a look into that and disassemble that. As it's known, there's some interesting stuff possibly in there for some versions.
Yeah, people speak about that.
Right. So just briefly about package format. Again, this part, the previous part was new research that we have done for BalCCon here. For NPK, we already covered that. So just briefly, so you understand the way the developers think. Again, NPK is used for either updating your router or extending functionality of your router. The file consists of a header, file size, parts, and footer. File size is the green one on the hex dump on the right. It is 8 bytes less than the actual file size, in case you want to construct your own NPK. Each part consists of the part type, which is short, 2 bytes, and of the payload size, which is long, or 4 bytes. You can actually see the separate parts quite nicely on the right. And of course, the payload follows in white. An interesting feature that we discovered just before SHA 2017 and didn't have time to test, now we tested it. So we discovered that there are at least 2 types of NPKs currently being used. There's the package NPK, which starts with this header, and there is restriction NPK. The official name for it is a restriction. We call it invisible package because when you install it, it's gone. It doesn't show up in the installed package list. And because of how the packages are being signed and what parts of the packages are being signed, you can actually swap the headers, swap the footers, and of course, decrease or increase the package size by 1. And you can make a normal package into invisible package and invisible package into a normal package. We will not show a demo because we decided it's quite boring, but here is a restriction package made visible. It's installed visibly. Restriction packages, well, what are restriction packages? What are they meant for, right? They usually are meant by resellers to limit your device in some way, usually regarding radio communication. So for example, if you buy one of those new AC routers in the US, you are limited regarding the spectrum and regarding the power. And we can't get our hands on any of those limited devices for now, but we believe that restriction package might be installed by the seller before shipping it out. It's of course normally invisible, or here we have it visibly because we changed the headers. And they also work for any minor version. So if your major version is 6, it comes with a specification saying it works from 6.0 up to 6 whatever. So here we can see it's happily installed on 6.3, 8.4. We did try the other way around because that would be major news, right? There's this Kalea package or lawful intercept for people in the US that MikroTik provides and it's publicly available. We made it invisible. We installed it. It got installed. It didn't delete itself because when you install the package, the package itself is deleted, right? You install it and the install file is deleted. It didn't delete itself, and we are not sure what happens there. I mean, it installs it successfully. The installer binary does it successfully. So we might look more into that, and maybe we are able to make normal packages invisible and they properly get installed. These are the types, the different part types inside an NPK file. So we've identified 24 of them, with, interestingly enough, 10 to 15 not being used. So of course, if you convert if you look at the type numbers in hex, which is the second column, you can see that my guess is when they were creating the next package, the next part type, as versions move forward, the guy who was doing that simply forgot that they're doing hex. So it goes 08, 09, and then 10 in hex, which is decimal 8, 9, 16, 17. So we couldn't find any. On our server, there's like a 5 gigabyte folder full of different NPKs. We actually wrote a script that downloads them all, and we couldn't find 10 to 15 used in any of those. Right, step out riff. We actually made quite a cool demo at SHA with subaltrif, and I want to say thank you to MikroTik. As usually, they fixed the vulnerability in 24 hours after I told them. So now we can actually tell all about subaltrif and how it's made specifically to the bit. Right. So subaltrif is generated like so, and it is a support output file. RIF probably stands for ridiculously intricate format, or maybe RouterOS information file. But we thought of the first one first. This is how it looks. It has many parts, like about 30 parts that resemble kind of certificates, but they're not certificates at all. Most of you here in this room will of course tell me, hey, it's base 64. Well, it is almost. After you do this, you take every 3 bytes and you swap the bits in those bytes around in between the 3 bytes. And then you can do base 64. And today, for the first time, we're actually including the map here. So you can play around with that. You can build your own subaltrifs. You can look at their own at their subaltrifs. The tools have been available online in our GitHub repository for quite some time after the SHA already. After you decode the base 64, you get name, then 0 byte, and then content compressed by zlib. If the previous slide was hard to understand, here's it again. We just created that map and basically swap the bits around, and then we can do base 64. So inside the subaltrif, we have your whole configuration of your router, like everything. It has the proc folder, so they can see what's running in there. So if you have jailbroken in your router, don't send them subaltrif. They might be mad because they will see it inside the pros, of course. It includes memory addresses for running processes, good for exploitation, I guess. Your log file, which is outrageous, I think, but for support reasons, well, we need this, right? And much more. The good thing is MikroTik.com actually has had a reader for those files for quite some time, and you can upload your subaltrif, or you can upload if you do services, right? If you provide network services to your clients, or you're just a distributor who provides 15 or 30-day complimentary support for setup problems, your client might send you a subaltrif that you can upload online, and that you can then take a look in what's inside and what's working and what's not. But it won't show you everything. There are actually some parts that start with a dot, and those are not shown in the web browser. Well, that's why we have this decode subout.p available in our repository. Let's do a couple demos here.
All right. Okay, so here is the subaltrif file that was used to. Are you talking about the exploit already?
No.
No. Okay. All right then. I suppose you can just open with TextEdit. Yeah.
Right. So these are the sections contained in that subaltrif file. Our script decrypts them, if we can call it encryption, and then decodes them, and then decompresses them, and here we go, right? So if we take a look at file number 1, address, which is also the first partition, the first part, and the first actually automatically loaded when you open the file in. Can we get a larger font? When you actually open the file in the browser through MikroTik.com. So we crafted this small file, we packed it back into subaltrif, and we exploited it live on the stage of SHA. And this is how it looked. So we have attacker window top right, and we have victim on the left. As you can see actually in the menu, your account actually contains your billing information. It has the ability to automatically charge your credit card and give you a new key for a MikroTik router. And if you send your file to your support person or to someone else and they upload it here, then attacker will of course get the session ID. And then you can quickly log in and get the credit card or get some new keys and go home, right? Because those keys that are actually given out using MikroTik.com do not need internet access. They have no internet verification. It happens all on the device offline. So you go there, you rob the bank, and that's done. Right, so this is how we did the exploit at SHA. Now we can show you. OK, thank you.
Can you switch back?
So this is breaking research made especially for BalCCon. We took a look at the config file format and how MikroTik stores its config file, because there's a lot of commands and you can set up a lot of intricate stuff, and it's quite great actually. And before version 2.2, XML was used, which was also nice. But then again, they only had like 10 features back then, and now they have thousands of features. So it's not really that useful. But we did manage to take a look at the configuration and how it's built. So config is stored in /rv/store. rv stands for read-write, of course, which means that's a great place to create your /bin, for example, or /rcd. That path will find automatically on boot for you. Config consists of many separate files. Like for every command, sometimes for subcommand, there is a config file. If the config is complex, then we can also have folders, and folders have sub-settings, right? Anyway, every settings file consists actually of two physical files, index and data. So we're going to take a look at the index, and we're going to take a look at data. As an example, let's take the most common ones, right? Index is the first file that's being read, and the last file is being written. It consists of groups of 12 bytes, so 3 longs. There's the record ID, which basically indicates the number. It can be an arbitrary number of the record in the DAT file. There's length of that record in the DAT file, and there's a separator, which is mostly for 90% of the config files, it's 5000, but for some it's something magical, like 4000 or FFFF actually, and but it just works. So we think it really doesn't matter what the separator is. Anyway, if the record ID is all Fs, it means it's not really a record, it's just an offset. And how does it happen? It happens when you change your configuration. MikroTik is, of course, new devices use NAND, and you don't want to write to NAND memory too much. So what actually happens when you change configuration, it doesn't erase your old configuration. It sometimes writes partially over it, but the DAT file will still contain your old passwords, your old users, well, partially, but it will be there, your IP addresses, maybe your log files, and you will just have this FF record ID, which indicates that you skip over that when parsing the file. Now the DAT format. It consists of 2 bytes of length of the file, then, length of the record, and then M2 record starts. It actually starts by M2 ASCII, capital M2. It's followed by config ID for 3 bytes and type for 1 byte. Now, I did spend quite some time trying to decode what those types are. You can see my attempts on the top right. Then we found out some interesting features, which we're going to share in the next slide, and it became much easier. So the field IDs, and by field ID I mean, for example, if, let's say, you add a DHCP server on a specific interface, then that interface name has a specific field ID of 3 bytes. Every DHCP server that you add, the interface name will have the same field ID that identifies the field. Value will be different, field ID will be the same. But those are just 3 hex bytes, which is hard to work with. Another thing that we found out is that Winbox protocol, which we will surely look into further and deeper, is derived from the DAT format. It has additional header giving you length of the packet, but everything else is DAT file, verbatim. We haven't disassembled it yet, but we suspect it might be working directly with .dat files, which is not that good, right? That might be dangerous. So field IDs we can get in multiple ways. We can change something in the router and take a look at the .dat file, how it changes, right? We set interface enabled, and we see which byte changes in the file. And we look at the field ID corresponding. Or we can use the web interface. There is neat function written by MikroTik, not by us. And we add the second line to it that logs the request. Oh, why do we need to do that? Because they implemented their own RC4 PPP-like encryption on their JSON requests in the web interface. Apparently to prevent managing SSL for routers, which is a problem, truly, right? Managing SSL certificates for IoT devices is a pain for now. But they wanted to solve it this way, which really doesn't help that much because without HTTPS you can't set HSTS, right? And you can just grab everything when the user goes in via HTTP and yeah, well, so that's why we can't just look at data in Wireshark clearly. That's why we add this, and then we see the requests in pure JSON, and we can identify which fields are which. And also there are these JGay files, which actually just is a huge collection of every field ID, description of it, possible values, and the types, and it's beautiful. But we will talk about that probably in the next presentation. Right. So. No, Nick, you don't have to go like that, because I mean, if you set a password in your device, it has to store your password somewhere, right? Well, encrypted, hopefully, but it has to store it somewhere. So, user that has your passwords, because it has to have your password. Luckily, those are not in plain text. So that means we can't just use this magic. Oh, by the way, I forgot to mention, today or maybe tomorrow on the GitHub we are providing a Python library for parsing .dat and IDX files. You just specify a name of the file and it gives you a Python object. Perfect, huh? Python dict. Right. So we can't just use this magic library to get the password because it's a bunch of garbage. Usually 16 bytes. If the password is longer than 16 bytes, it becomes 32 bytes. If the password is even longer, it becomes 16 times 3 and so on, which smells of CBC if we're lucky, or maybe something even worse. Right. So we do this. Yeah. So the binaries that are responsible for checking your password, take your username, add some string to it, I don't know, and that's your key. Oh, it creates MD5 digest, which is, of course, 16 bytes long, huh? And then it cyclically XORs it with the password field. And there you have it. That's your clear text password. And it works both ways, of course. You know, that's a nice feature of XOR. Right. We are actually nearing the end of our presentation, which is good. Now we're going to take a look at routing process. Frankly, we have shown routing process at SHA live. We hope that it's going to work nicely here. And well, we have added some new features, and we are still working to add even more features and make it easier for you to route your router, either for interoperability purposes or if you want to actually develop something and you want to contribute to the community. That would be also great. Right. So generally, since they have this built-in backdoor, as I said, it's quite easy, right? You just create the file and you have devel access. Well, first question is how do you create the file, and why the hell don't you have ls? Because it really messes with your ability, right, to hack the system properly. Well, not really. You do this, right? And it of course has bash completion. So ta-da, we don't need ls actually. But I mean it's not nice, right? It's hard to type so many characters, so we can upload BusyBox and yeah. So we use this version. It's an old version, but it has many different architectures, which is nice because MikroTiks come in many different architectures. If we don't want to do all this manually, we of course have VirtualBox appliance, and we are releasing a new version today of the old appliance. Unfortunately, it still supports only the same devices as previously, but it has some neat features, right? So for those of you that haven't seen the previous presentation, here's how you use it, right? You import the appliance into VirtualBox. You double verify that the bridge network card is set to your Ethernet adapter on your device, on your laptop, for example. You disconnect all other wires from the router, and you power it up. You start the virtual machine and follow instructions. And that's it. Be ready to swiftly replug the cable, because actually at one point there are about 5 seconds that you have to do it. You don't have much time at that point. Right. So because of this nice feature with the passwords, that's the new feature that we're adding to our VirtualBox, to our container, this conference. You've forgotten your passwords, your mother has forgotten her password, or your colleague has forgotten, or your boss, or someone has forgotten their password, not a problem. Okay, let's do a demo.
So I'm just going to quickly start up the VirtualBox.
Right, so this is our 0.89 version, right?
Yeah, should be. Hopefully.
Yeah.
Yeah, it's that one. So set it to the correct adapter. Okay, so you set it to the correct adapter in the VirtualBox, and now we're going to go through the process of finding the password. Here it asks, do you know the username and password? If you say that you know the username and password, you can go to the previous process of routing the router. If you don't know the password, then just say no. And then it's going to say, all right, that's fine. Plug the cable into port 1.
This is the hard part. You need a lot of hands for this, but as Jans is showing, one person can do it.
So then you hold the reset button, then you plug in the power and click enter, and now I just have to hold it steadily.
Okay, let's pray that everything works. This actually, of all the demos I've prepared for different talks, this is the most flaky one. We didn't get it quite stable, but let's hope for the best.
All right, let's see.
So now, at this point, you have approximately 3 seconds to release the reset. Or if you hold it too long, then something bad happens. If you hold it not long enough, then something even worse happens. You lose your config. That's why you back up your stuff if you can. I mean, if it's your router, you can back it up, right? Mm-hmm. So now we're feeding the device with some... oh, nice. Yeah. You just do what it tells you, right? Now it will hopefully start up our own SSH server on port 2. This is OpenVRT running there right now, so that's not related to MikroTik. The software running. And we are trying to do some nice things. Now, this shouldn't worry you, because this doesn't worry us at all. This sometimes happens, but the script is super robust, and even if it goes into full screen saying connecting, in the end it will connect, right?
Maybe. Yeah.
Actually, when I was showing a similar demo at SHA, it also had like connecting for the whole screen, and if not connected to the projector, it doesn't have that many connecting. Maybe it's connecting to the projector. Well, anyway, it extracts the user data and user IDX. Oh, look at that.
Oh, so that's the password. I had forgotten it.
Right. I actually, writing this, I tried to mimic the output format of /user print on the router. You will also have IP addresses here. If those are limited, if you're limited by IP address, and last login time, of course, and the comment, right?
Yeah. So should we continue with jailbreaking this one?
Yeah, why not, right?
All right, let's try. Hopefully this works as well.
So if you notice, we actually didn't even have to type in the IP address. So if you've forgotten the IP address of your router, that also works. Right now it tries to jailbreak it. Anyway, you should write this password, well, not this password, but your password down, because you will need it to log in later on into admin or into the newly created Devil user. Right, so this is the previous jailbreak from SHA. And that's it, basically. The router will now reboot, and Janis will demonstrate that Devil is there, that we actually managed to upload BusyBox binary, that we have ls, and they can easily roam around around the device.
Yeah, just a second.
Maybe a bit larger.
Yeah, just a second. So just log in as Devil with what was it?
Yeah, right. The question was the password. That's why you have to write it down. Oh, okay.
All right, I'm in. And we have ls. Great.
Yeah, so we fixed that.
So there you go.
Type ID. Do we have ID on there in the bundle?
Yeah.
Yeah, there we are. Oh, thank you. And this works, of course, because all the processes are running as root, right?
Yep.
If you type PS, I think we can get all the processes running as root. But we are ready for them to implement privilege separation. I mean, since it's quite an old kernel, we are ready for them.
Maybe in version 7.
Maybe in version 7. Right, so that was the demo.
Can we go back? Slide.
And let's go back. Right. It's actually everything that we had for you today. I hope you had fun. Oh, we also have the OVA file, right? Tools are there. Some new tools will be uploaded tomorrow to the GitHub. So yeah, if there are any questions, now would be the time.
Are passwords also stored in a subout file?
Yes.
So every time you send it to MikroTik or give it to your analyst, he can get the passwords out, right? Are they readable or?
I understand what you're saying. Well, they are readable in the file system, and we know how to decrypt them. And rest assured, MikroTik knows how to decrypt them. Come to think of it, I'm not sure if the contents of the folder actually are part of the file, but we could do that test tonight and upload the results on our Twitter account. So because it doesn't actually upload the binary config files, passwords are stored in the backup. So if you just if you don't know what you're doing and you send backup and subout ref to support, then your password is there.
Okay, thank you.
Have you done, I know this is kind of tangential to your talk, but have you ever looked at using the dude on remotely exploited MikroTik devices to find out more about the network layout where these devices are working, or to find out things from other devices using the dude that you wouldn't be able to use if you just had BusyBox tools on the exploited device in the wild?
We do know that you can easily run dude using Wine. But since it is a Windows application, I have personally never used it. Have you ever used it? We haven't done research on it, but we have never used it. But we will look into it. We will look into dude. We read online research of one security researcher that told it is possible to actually exploit dude using backdoor DLLs, because well, I did look at some packet dumps actually, to be fair, but I didn't go deeper. Dude, when connecting, it actually may download DLLs from the router at some point, and if that router isn't a router, but a honeypot, or I don't know what's the right name for bad honeypots, right? Attacker device, then you might actually get bad DLL. Clearly for Winbox, maybe also for dude. Yeah.
Just from a development standpoint, from MikroTik, why do you think they're so reluctant to go to a more recent kernel version?
Well, GPL, right? I mean, they have to. You can't just apply your patches to, say, Linux 4 suddenly, right? So, and then you have to comply with GPL requests. I mean, they try to do their best to not get sued, but they are quite reluctant to comply with GPL requests. The standard answer that you get when you ask for GPL compliance, good thing, they don't actually ask you to send the $35 anymore to get the CD, even though it's still in the license. But the standard thing they do is they send you a link on their server, a normal standard link, permanent link that's always there. If you ask for more, then they start finding, well, I mean, it takes time, right? And if you change kernel version, you have to check that all the patches, because they have patched a lot. Janis installed 10 megabytes of patches for the kernel. It takes time, yeah. But I think version 7 might actually come out with a different kernel, even though we've only seen 2 different kernel versions for RouterOS 2 to RouterOS 6. So for all those versions, we only seen 2 kernel versions. Okay, I think we are out of time. If there are no more questions, ask us questions on Twitter. If you want to join research and if you have some skills, that would be appreciated. We would surely have some fun. Thanks.
Thank you.